Good evening, everybody. Welcome to Shop Talk, hosted by the Triangle Area SQL Server Users Group. So tonight, fun story. Mala messaged me earlier today. He's like, "Sorry, I'm not going to be able to make it." That's cool. Tom messaged me earlier this afternoon. He's like, "Sorry, I won't be able to make it." Okay. Tracy messaged me earlier today. "Sorry, I won't be able to make it." I'm like, I'm not saying I'm feeling abandonment issues, but it's going to be just me tonight. Me and the wonderful chat. So Shop Talk is a chat-driven program that is all about answering questions, sticking mostly to the data platform world. Although, frankly, if you don't give me enough content tonight, I may just veer off into inanity. But, I could have called Anders. Well, Anders, you can hop on if you want. But then you wouldn't be able to play your video games. That's the problem. So the official agenda, which is actually different from the secret agenda, is, do I have Amazon Echo? No, I don't. I don't like Amazon knowing everything about me, despite the fact that I have enough information about me and Amazon that they still know exactly what I'm doing. But we're going to talk tonight. I already talked about item number 1 on the official agenda. Where did everybody go? Look at that. We knocked something off already. And at this rate, we'll be done by 7:10 p.m. But if you have questions, drop them in chat. I'll answer them. I will definitely prioritize them above what I've got. There are a few things going on in the official Shop Talk agenda. I keep saying official. Yes, there is a secret agenda, the Duke. The secret agenda is actually pretty much the same as this, except it has some of my answers. So that way I can look over this way and make it look like I'm actually thinking, when really I'm just reading what I wrote earlier today. Now that I've let all of the secrets out, also Tom, Tracy, and Mala don't actually exist. They were all just complicated simulations that I put together. We're going to go with that for at least 1 week. So this evening, first thing I wanted to hit, this is something actually that Mala brought up a while ago. But what is a Jupyter book? And we've talked a little bit about notebooks. I've got Azure Data Studio in my background for a reason, because we're going to spend some time in here today. And one of the first things that I want to mention is, all right, what is a notebook? Most of us at this point are probably familiar with the idea of notebooks. Let's go me on the bottom, where you have the capacity to connect to an instance of SQL Server, or if you're running this on a full Jupyter Notebooks installation, perhaps you have R, Python, or whatever. You can add code, you can add text. So you could say, like, select top expense reports. I don't even remember what tables are in expense reports. Let's go with calendar. I love calendar tables. There we go. We have elements in here. I can add comments. I can add text. I can add markdown blocks, excuse me. And tie it all together with a nice ribbon. Make this one coherent thing. So there's this relatively new thing to Azure Data Studio. I say relatively new. It came out well after notebooks, called Jupyter Books. So if you look over here, we've got notebooks. Howdy, John, Fan, and Neil. So here we have, I'm actually going to collapse all first. Here we have notebooks, and I can open up these notebooks in sort of a one-off fashion and maybe store them all in a folder on my, in some directory someplace. Or we can tie them together with Jupyter Books. So here's a great example of a Jupyter book. It's by, let me pull up. Let me pull up the website here. Nothing risky about me randomly searching websites. I'm gonna just search it in Google. There we go. So it was tsql.tech. Okay, so Emmanuel puts together some different resources. And included in this, oops, I meant to hit blog instead of RSS, but included in this is, he's got a blog, he's got some nice articles, but he also has this thing called the SQL Server Diagnostic Book. And you can find that on GitHub on Emmanuel's page. Let's zoom this way in. And in here, he's got quite a bit of stuff for various things. One thing in here is notebooks. So various things, meaning if you want query store related queries. So there are some queries that he's gathered over the course of the years. But in here in notebooks, there's a notebook for a diagnostic query. So inside here are some Ipython notebooks. Now these are, you might call them loose leaf notebooks. And I'm using that analogy on purpose because they aren't tied together formally, even if they are tied together logically, in that they're in the same directory and they all kind of deal with the similar problem. Just, is this for different versions of SQL Server and how we would handle the specifics of that. So those are just standard, bog standard notebooks. But in here, there's a book, the diagnostic book. The diagnostic book is a little bit different. You'll notice it's got some directories with underscores and content, assets, scripts. This is something that is put together through a different resource. Usually I'll see this in, say, RStudio will allow you to build knitter notebooks and be able to put together books that way. Jupyter has its own facilities for creating these books, but essentially it's run programmatically and it builds up an entire set of notebooks. So if I come back to Azure Data Studio, I can go to Open Notebooks and Folder, and I've selected the diagnostic book, and that's why it pops up here. Now it shows up as an entire book, and in this book you've got, say, a home screen that you can learn about the different scripts that Emmanuel is using in here and bits of information. There's a link to his blog, which I could have just gone to at the beginning, but I needed to randomly hit Google just in case. And other different sorts of notebooks that give you an idea of how to, say, run the SQL Assessment API or use Eric Darling's SP pressure detector. So this is a good way of bundling together groups of notebooks that are related and still letting them be independent individual notebooks, but having a table of contents, an index, bibliography, having the ability to connect these resources together in a way that simple loose leaf notebooks won't be able to do. And I'm clicking on the wrong one. So there are some books that are potentially provided. Like, for example, if you if you connect to a big data cluster, then you'll see some provided book for managing a big data cluster. It'll tie together all of the different resources. Some of the folks at Microsoft have put together a book that is sort of part of their troubleshooting guide, and they've made it available to the general public. So those work out pretty well. The Duke mentions Jupyter Books reminds me of iPub Books. Can't quite explain it, but something about it. I guess I can kind of see that. That wasn't the analogy that I initially came up with, or EPUB Books, okay. EPUB Books, yeah, so I guess it's probably in the way that they're formed and how they're kind of knitted together, as opposed to being just a bunch of individual notebooks. Let's see. John Fan says calendar tables are good for planning for presentations. Calendar tables, you know what? Let's talk about calendar tables. You said that as a joke, but I'm going to take it seriously because there's nobody here to stop me. That's probably for the worst. So, all right, a calendar table. Oh, thanks, John Fan, for the link to the Jupyter Book website so that you can learn how to build them yourself, should you be so interested. So calendar tables. Calendar table is essentially the same thing as a date dimension, but outside of a data warehouse experience. The whole idea here is I don't want to have to run any sort of function to determine, based off of a given date, what that value looks like. So in other words, you give me a date in the database, and this is, for example, January 5th of 1800. And if I want to know day of the week, day of the month, is it a weekend or not, I can store all of that information, essentially pre-calculate it. Now you can go even further. I have calendar year information, but suppose that you're at a company that has fiscal years and your fiscal year is not aligned to the calendar year. Well, you can store that separately. So this is fiscal day of the year 189, but it was calendar day of the year 5. Because in this case, I set the fiscal year to begin July 1st. So it was a 6-month stagger. And at one point, I worked for an agency where we had a state fiscal year and a federal fiscal year. The state fiscal year was July 1st. The federal fiscal year is October 1st. The calendar year is January 1st. All three of those dates and those time frames were important for us. And so in this one date dimension, or in this calendar table, I can store info on all three of them and be able to say, well, let me aggregate all the data for Q3, fiscal quarter 3 of 1800, and pull the information together. Now, one of the more clever things is holidays. Holidays some of them are pretty straightforward. New Year's Day almost always lands on the same day each year. I say almost always because as soon as I say always, there's going to be some exception. Sorry, due to current problems, we've pushed New Year's Day back to August. But say something like Easter or Passover. Let's say and year. Calendar year greater than 2000. So we're only going to start in 2001. So in this case, these are the different times in which I believe this would be the first day of Passover in this holiday table for each year. And you could say also Easter, you could say Orthodox Easter. Those are 3 different holidays in which the day in the Gregorian calendar is different from year to year. And so we have to store that information, or we have to calculate it. There is a way to calculate it. I actually have a blog post where I linked to a person who created a function to calculate all of this crap. Useful when you need to suddenly shut down trading, like after September 11th. Yeah, that's also useful, and you can mark that. You don't have to have this just be holidays and this information. You could have specific info that, okay, it was, yes, at a holiday, okay, a bank holiday. But you could also have a special note that, why was this number down? Okay, well, we switched over to a new system and weren't able to migrate over all of the old information. So data before this point and data after this point will be different. Or another example, you pick something like, this was the day that the Russians revalued the ruble. At one point, they knocked off it by a factor of about 6,000. And you can store that in currency tables and currency exchange rate tables. But you may also want to have a note in here because it can be hard to remember exactly what day that was. So calendar tables are extremely useful because if I want to have a function, let's say that, let's look at a different table. Here we have expense reports. And let's interjoin to the calendar table. Nope. I just wanted to call it ER on expense date equals c.date. Let's say where c.holiday name is not null. So now we can tie this together and say, oh, they never filed any expense reports on holidays. These people were great. They got all of the holidays off. And actually, I did that on purpose in the data set. So if you want to know what are the distinct holidays they get off, you might be jealous. Oops, calendar. Because they got lots of them, including Administrative Professionals Day, Groundhog Day. Of course, you get that off. You get all of the Groundhog Day off, every single Groundhog's Day. So they get a lot of days off. Leif Erikson Day, obviously an important national holiday. But let's say we don't want that. We want fiscal quarter. Let's say I want to break this down by fiscal quarter. So I want to get the sum of expenses, sum of amounts from the expense report, and I want to do it for every quarter. Then what I can do is say group by c.quarter. Let's say calendar quarter name. I'm going to say calendar quarter. Whether or not it sees its shadow, not only whether it sees its shadow, but whether Bill Murray can escape. So I can run this group by calendar quarter, and now I have the first, second, third, and fourth quarters of the year. And I could change this to calendar quarter name, and you'll see Q1, Q2, Q3, Q4. You might say, well, I want fiscal years or calendar years as well. Probably don't want fiscal years. So it's easy to include. All right, well, I'll just include calendar year as well. And then boom, I can order it. Probably order it before I say boom. John Madden would not be happy. There we go. Daylight savings beginning, is that a holiday? It is not for the people in this fake data set, although I'm sure they would agitate to make it one. So here I can break this out by calendar year and quarter name very easily. Now you can, of course, do that without the calendar table. You could use case statements. You can break it out case when the month of the year is whatever, then Q1, else Q2, else Q3, else Q4. But it is a little bit more complex logic. And as you start getting into things like holidays, where there are some really weird rules, it's just easier to spend the time, calculate it once, or frankly, have a person enter the data if it's that difficult to calculate. Things like Amazon Prime Day. Amazon Prime Day isn't something that you calculate on a yearly basis. They changed it this year. They've changed it a couple times already when it occurs. So it may just make sense to have a person update that table and say, this is Amazon Prime Day this year. Although they've renamed it to something else. So maybe that example isn't the best. But sometimes you just have a person update it manually. And that gives you the ability to perform very quick aggregations, very quick filters. So that's the benefit of a calendar table. I love these things. I have a script to create one. I have a script to add certain holidays. Please add more holidays as well into your own as you need them. Get rid of ones that you don't need. Probably not everybody needs to know when Lag BaOmer is. So that's Jupyter Books. Again, Jupyter Books are really useful tools. You can find some of them. Some people have put them on GitHub. I'll drop a link to Emmanuel's GitHub repo so that you can grab it yourself, should you so desire. There we go. And in this era of all of my co-hosts abandoning me, I just want to remind chat, this is your time. If you have questions, feel free to drop them in. happy to answer whatever I can and pretend that I know all the stuff that I don't. So, in other words, like every other episode. Speaking of things that I don't know what I'm talking about, let's talk about this question that the Duke brought up during a Data Architecture Day. So the specific question was, one thing I've always wondered is, how are people fitting subscription data to a star schema? So many businesses are subscription-based with through and from periods and not really based on a particular date. So how do we do that? And before I get to that, that was kind of a tease. Mike mentions time tracking is incredibly difficult. Yes, absolutely. Calendars are amazingly difficult. The things that people work with the most tend to be incredibly nuanced and detailed. Things like currencies and time are two ideas that seem like they're simple, except every time you start trying to standardize it, you realize there are so many exceptional cases. And that's before you get to thinking about time like, well, the thing that I've been hinting about but never stated out loud, quite a few holidays are based on lunar calendars. Chinese New Year, all of the Jewish holidays, some of the Arab holidays, or Islamic holidays, Easter. These are based on lunar calendars. They're not going to be the same every year in our solar calendar. And our solar calendar has its own oddities. We talk about leap days and leap years. We have leap seconds. We have, like you mentioned, time zones. People have weird rules around time zones. Some areas don't have them. One of my favorite bits of time zones is that the Mountain West part of the country is on Mountain Standard Time until they're on Mountain Daylight Time. Arizona doesn't follow Daylight Savings Time, so the entire state doesn't follow Daylight Savings Time, except for the Navajo tribal areas in Arizona, which do follow Daylight Savings Time. So you can drive and cover about 3 different time zones in a fairly short amount of time in Arizona. And that's just one little political bit there. China has one time zone for the entire country. Certain time zones are 15 minutes off, 30 minutes off. So it's very strange. People like their nuance. If you want to deal with Julian calendars versus Gregorian, well, first, if you want to go back far enough, the Gregorian calendar lost several days at one point. And we've got all of these oddities to deal with. We tend to ignore them for the most part because in most cases it doesn't matter that much. But when it matters, it really matters. And if that's not a truism, I don't know what is. Solomon mentions SQL Sharp having business days and is business day, and they can calculate Easter for both the Orthodox and Western churches, as well as conditional day off for Christmas and New Year. So that's also something I didn't even mention, that the day off. Egypt changed daylight savings dates to fit better with restricted eating schedules in Ramadan. This happens. The U.S. changed daylight savings schedules not too long ago, and they may change it again. There's about this 1 to 2 week gap between the U.S. and Europe, and it's kind of annoying to people who have to deal with both sets of time zones. So yeah, it's all very weird. Anders stayed in a hotel that traveling through the hotel was a different time zone. That will happen. And my parents always call in the worst part of it. Yep, that'll also happen. So there's a lot of nuance in here. So let's talk about additional nuance with subscription data in warehouses. How's that for a transition? All right. This was a really good question, and I spent some time thinking about it. It was like, okay, the easiest way that I can think of an answer is actually to create a subscription dimension. And in that subscription dimension, we have period begin and end dates. And then in the subscription dimension itself, we'll add in some data. So yeah, I've got a subscription. This is laid out as a type 2 dimension. Period begin and end dates is current row. I have a subscription key, and I made up the source subscription ID. Who knows? I have a user key and a level. So somebody's at a certain level for a time frame. They can join, they can leave, they can upgrade or downgrade their service. All of that stuff happens in real life. They can try to downgrade a service or leave, but then the company doesn't actually take them out, and you have to call them 5 or 6 more times in order to cancel your subscription. Let's not talk about which cable company that is. So we want to add a couple of people to this. So we have our subscription information. User 1 has a gold subscription. Joined our service in May of 2020 and is still an active member, so the end date is the end of time. Fortunately, there will never be a year 10,000, or if there is, I don't have to update the database. User 2 came in at the talc level on April 1st of 2018, and on December 1st, upgraded to zirconium status. And by the way, these two dates are overlapping here because I'm going to say where the period begin date is greater than or equal to a certain date and less than period end date. So there's going to be that change in the query. So that way, essentially, I could add a time component as well if I needed to. But that's why you see exact overlap. You could also write this as saying, nope, this is going to be 11:30. But just the way I'm writing the query. It is something we have to take into account. User 3 came in at quartz level in November of 2017, and after 1 year of service decided to downgrade to amethyst level, and then left us in 2019. So we've got different statuses for different users over time. And the scenario here is that we have a subscription service for watching training videos. And so here's our fact table, our fake fact. We have the date when the person watched the video, we have the course that they watched, the subscription of who watched it. Notice that I don't necessarily include the user because subscription actually has user. And in fact, if I'm generally going to group by subscription and think of the subscription level, I may just include all of the user attributes on here. Even if I don't, I'd probably still include them. But if you normally group by user, then we could always add a user key if we needed to. And what other keys we need? A number of minutes that they viewed, number of segments viewed, and did they finish the course? Just giving us a basic fact table that we can work off of. And in this subscription model, we want to know when they watched it and when they had access to our services. So user 2 is currently zirconium and is now upgrading to topaz. So they've upgraded to our topaz tier. And upgrades in level, changes in level, I would treat as a type 2 slowly changing dimension. So what that means is we're going to update the current row, set its period and date to now. It is no longer the current row, where the subscription key is equal to 3. I know it's 3 because I put in this example myself. But we would go search, find what the key is, and update it. And we would insert into the subscription table the new record with topaz level, starting today, going to the end of time. So I'd be able to update that and handle it in one transaction. If user 1 leaves us, they're just changing the end date. So we don't have to add a new row. We just have to update the period end date. In that case, we treat it essentially as a type 1 change. So that this existing row, I need to update it, I need to handle it. But I don't need to add a new row that says subscription service ended or anything like that. So that was my first pass approach at how I might handle a subscription style for facts, where the fact has a date. We do care about the date outside of the subscription. And our logic for setting the subscription key would have to find the record where the period begin date, like where this date in our fact table that we're loading up is between this range for our user. And then you do that lookup once, but now I have the subscription key. What this allows you to do is it can let you say, hey, show me all of the people who have subscriptions that are expiring in the next 3 months. So I can look where period end date is within 3 months. By the way, I left this as forever because I said once you're in for good. But if you have an annual subscription, we could fill it in like this and say that's your annual subscription, and when you renew, if you renew at the same level, that's just a type 1 change. We don't have to add a new row necessarily. You could add a new row if you wanted to. If you needed to have that, if you needed to track the update history, in that case you could have additional rows and you'd still look for the one that is current and try to find the right answer for your query. But if you're looking at all the active customers, to make this easier, we could say is active equals 1, or we could look for, in this scenario, everybody who has a period end date of forever, or at least a period end date in the future. Maybe he calls us up and says, I'm going to cancel my subscription at the end of the month. And then we would update it. Oops. Instead of 6/8, we could say, all right, well, 6/30. So you still have a subscription, but come 6/30, you're gone. You're out the door. And you could also look at other things on the dimension side. If you care about the number of times a person has renewed, maybe if you care just about the number and not about the exact dates of renewal, you could store that number as an incremental update as part of your ETL process. If you care about the individual dates, then you treat this again like slowly changing type 2, where you have from this date to this date, you were a gold member and you paid this much, you were billed on this date, you paid your bill on this date. And then we have the next update. I think one of the keys to having this subscription work is I don't have many other things that change on the subscription itself. So I don't have 40 or 50 attributes that in the event that one of them changes, I need to go and update. Or at least have a type 2 update. Type 1 updates, have as many of those as you want. So for example, something like I could have all of the user data be type 1, because for the subscription, especially if I have a separate user dimension, I don't necessarily need to worry about what was the subscription detail like before person changed their last name. It's not usually the type of query that I would expect a reporting system to cover. Might need to know that for a user dimension if we do user querying, but probably not for the subscription side. So having relatively few type 2 attributes, level being one of the most obvious ones, and maybe not having that many more, really makes this work probably about as well as it can work given the problem domain. So the Duke, if you have anything you want to add to this, any complicating factors, reasons why this wouldn't work, feel free, drop them in chat. We'll talk about them. And if anybody else has thoughts on this, I want to hear them. This, I think, was a really interesting problem. This is not something you normally hear very often when you're talking to people about data warehousing problems. we tend to think about dates as points in time rather than ranges. And having to think about that range, it took a bit of creative effort for me to come up with something like this. So if there's a better solution, I am all ears. All ears and hair that needs cut. But that was my demo. So the Duke mentions, how do you turn this slowly changing table to work with outside dimensions, getting counts of active subscribers by day, or a day level and gender from a subscriber table? So if you had a subscriber table, you're going to have these subscription values. You're going to have these subscription values. You may also have a user dimension. So, okay, we're going to join to the user dimension and say, here's the gender and the day level and gender. So now what you would do is we're going to tie this together. We're going to tie it back with this section. So let's say I'm going to do this in a brand new cell. I mean, that's what notebooks are for. Now, I'm not going to bring it in with subscriptions, but I have employees in here. We have employee, we have calendar, and if I have, you know what, I'm probably going to bring subscription in. So let's, and I think I have those employee IDs. I think I made them obvious enough. So let's try doing this. We're gonna wing it. We're doing it live. Doing it live, people. So then I have employees. I have subscription. Employee ID equals s dot user key. And for the calendar, I want to know every day that they are. Let's do this. Let's do this. All right, so we have an employee dimension, an expense report fact, a subscription dimension, and our good old date dimension. So expense date is equal to date. And what I can do is, if I'm interested in all of the dates in this period, I could cross join. And what that's going to do is give me one row. So I could say where c dot date is greater than or equal to s dot period begin date, and c dot date is less than s dot period end date. And then that'll give me one row per day per element. And if I don't include the fact detail, then this, like if I just wanted to say, show me essentially a big matrix of all of the possible days and employees, that's where we get here. And then I can say left outer join, and c dot date equals er dot. Oh, what did I do wrong that made this all angry? IntelliSense is angry with me, and I can't remember my table. I probably should know the table, seeing as how there's only a few columns on it, and I created it myself. But it's called expense date. So then, what I have is calendar year, calendar quarter name, s dot level. So my subscription level, employee name. And this is all me. This is me all winging the query, so it's probably going to fail because I forgot a group by, or I forgot all the elements in my group by. I'm surprised that that's the reason it failed. I'm sure there will be other reasons as well. There we go. And let's order it by, say, c.calendar year. And so Jack Aubrey was a gold level. Jack may not be the best person to care about. Also, my calendar years are all goofy because I messed up the query somewhere. But this is the general idea here. Oh, wait, no, it's not. It's not that I messed up the calendar period. It's that, remember, we go on to infinity. So if I come into somebody who actually changed, like Steven was one level. So you can see that Sophia was quartz and then went to amethyst. But spent some time in quartz during this level, during Q4 of 2018. And then went to amethyst. Steven was talc, zirconium. So we can see the different changes over time and the amounts there. And this is something that we could also say, they didn't go beyond 2020, so I can just drop this and say, all right, here's what it looks like for people over time. So the Duke mentions, all right, here's the challenge. What if your query is humongous and you're worried that query timeouts or whatever other restrictions, like memory restrictions in the queries? Would you create an ETL process to materialize historical membership? And if so, what techniques would you recommend to make the query efficient? If you're talking about a warehouse, I am all for materializing as much as possible. If you can, if it's something that you can pre-process, then I'd say go for it. So let me give you an example of something that is really difficult to pre-process. And let me switch to big camera for a moment. So I've worked with a data set which was fact data that could be aggregated across a bunch of different lines. And those different lines, so the different dimensions, but within a dimension, the date dimension, they could say, I want arbitrary calculations over arbitrary timeframes. So what I mean by that is I want to be able to select the beginning and end date and also perform aggregations and filter on those aggregations. If that's a necessary part of a solution you provide, then materializing isn't really going to work. If you can define the queries to be run, you know the exact queries to run, then I would absolutely materialize. I would definitely try to create the facts and dimensions at the grain that people are going to ask for it, even if that means having a fact at the lowest grain, another fact above it, another fact above it, and another fact above that, that all represent the same thing, just aggregated different ways. I have no problem with that in a Kimball warehouse because you have the one ETL process handling all of that work. And I would rather throw a lot of resources at it during the compilation portion, the data loading portion, than during data retrieval. Especially if you do have expectations that there's a lot of data and queries are going to fail. So yeah, I would push for that. In the case where I was talking about where you can aggregate by arbitrary timeframes, the best that I was able to do was get the data by day. But then beyond that, essentially, I still needed to have all of the breakouts that are possible, all of those different dimensions that we connect to, and have it at that grain, because they could select whatever attributes they wanted, whatever dimensions they wanted to filter on, and I had to be able to perform those calculations, perform those aggregations, and then give them the possibility of filtering on it. So it's kind of nasty because those aggregations were also date frame based. So like what is the calculation, which is not just a sum, but is includes division, includes subtraction. So it's not just an additive fact. What is the value? I'm trying to be very generic in this and not spill too much info. But being able to do that by day, I just wasn't able to get it aggregated any higher. However, if I could have gotten them to say, okay, we'll let you do a 7-day, a 30-day, a 90-day, a 180-day, I could easily have created 4 separate tables with those 4 levels and said, here's what your calculation looks like at 7, at 60, at 90, at 180, whatever numbers I threw out, and have those be separate fact tables and query those separate fact tables based on what they input. And then I could index those tables differently, where you're asking, would you do this in a column store index? And the answer is quite possibly so for the 7-day, because I expect I'll have a lot of rows and I'm doing summations and aggregations. But when I start looking at some of the higher level ones, I'm actually doing more like point lookups at that point, or I'm doing a small range lookup because I've already pre-aggregated all of the data. So now it's, give me this subsection of data for this customer, and you can ignore the rest of the data. And this is hundreds or thousands of rows and not tens of millions. Whereas if you drop me to the fact table, I may have tens of millions of rows aggregated across from tens of billions of rows. And in that case, clustered column store indexes are a beautiful thing if they're designed appropriately. So hopefully that helps a little bit. But yeah, my general philosophy, and I don't think it's that much of a heresy, but my general philosophy there is, if you can materialize, pre-aggregate, store this information up front as part of your ETL, and it doesn't completely annihilate your loading window, then go for it. It is much smoother of an experience for an end user, and I think that's the most important thing if you're going to get traction on a warehouse project, is it has to be smooth for the end user. Waiting 2 hours for a report or 90 seconds and getting a bunch of timeouts, that's a good way to get people to stop using a product, unfortunately, and is one of the reasons why data warehousing projects tend to die. So John Fan asks, how many times do you present it in different conferences? I present a lot of things at a lot of different conferences. I have lost track of the number, to be honest. It was somewhere in the 40 to 50 conference range last year, but it was much smaller this year for several reasons, mostly because I can't get out of the house. So I'll see if we have any other questions on subscription data, because I think that was, I enjoyed the topic. I enjoyed the chance to think about it. And if there's anybody else in here who wants to drop some knowledge, I would love to hear. Neil stopped counting when he hit 400. Yeah, that's fair. Like once you hit that point, you're like, you know what? It's big. It's a large number. Once that integer overflowed. So many businesses try to use subscription modeling or software as a service, platform as a service, etc. Yeah, subscription modeling is taking this away from SQL Server for a moment. Subscription-based modeling is a fantastic route for modern companies because you Couple reasons. Number one is that you flatten out your revenue. So what I mean by that is if you have a monthly subscription model, you know that you're getting money every month from customers. You don't have to worry about waiting for the next time they buy the product, which might be 3 years, 5 years, 7 years. The second one is even so, monthly subscriptions are about the smoothest that a company can ask for. Annual subscriptions have some of the benefits of the monthly side because you still have a reasonable expectation of flow coming in, but it's not quite as nice. Like monthly, even though people drop off of monthly, you just have that accounting increased likelihood of revenue or of revenue knowledge, and you can plan for it a lot better. The historical model of selling a product, of selling a license to a product one time and then waiting for somebody to buy the next version, it still works. And as a consumer, I like that model because I can choose when to upgrade and I can decide, you know what, I just don't need to upgrade. I've paid enough for this. But that idea is you pay a large amount up front, and ideally with the subscription service, you have that relatively lower amount that it probably adds up to more than the package product, but it lets me essentially amortize the cost of the product over the lifetime of my use. So yeah, it's definitely becoming a more popular option for companies and is essentially the standard method for a lot of web-based services nowadays. Amazon Subscribe and Save is a great example of that, or Prime and Audible, Twitch. We're on Twitch right now. Amazon owns Twitch. You have monthly subscriptions. You can't subscribe to TriPass because I've never set that up. But if I wanted to set it up, I don't know why I would. I don't really gain anything from it. But you could see advertisements. More advertisements. Nonetheless, yeah, that subscription model is not going away anytime soon. It makes too much accounting sense and is too good for a lot of smaller companies. So I want to wrap up tonight, talk a little bit about how bad is that job description. And this comes in from Mike Christensen, who gets emails from people. And got an email about a job, full stack developer, plus DBA, plus Salesforce support, needs to know ASP.NET and C#, SQL development, reporting services, needs to be able to interface with businesses. I looked at that and I'm like, that's not a terrible job role if you're a senior level developer and you're not expected to be really good at all of those. But at $350 an hour, as if. But we see these a lot where what happens, I think that this kind of boils down to maybe 3 or 4 different reasons. And the first reason that I know of, that those are the $35,000 a year job. Anders is absolutely right. That's the one where it's like we need one person to do all of the IT staff because we laid them all off. So the other side, the part that I find generally even funnier is this was a while ago. This was back in 2014. You needed 3+ years of experience with SQL Server 2012. I'll let you do the math while I take a drink. Almost as funny as the one time, no, actually, I've never seen a job description. I've seen resumes talking about SQL Server 2003. I've never seen a job description that requires it, which is a shame, because I know people who've got SQL Server 2003 on their resumes, and they could apply for this job. 1999, Anders considered moving to Norway. One of the jobs required 5+ years of .NET. Mind you, .NET had just come out at that point. In fact, I think C# wasn't even a language by 1999. It was still under development. If you started with RTM, you could get 3 years of experience in 2012 in 2014. Not really, because it wasn't released on January 1st of 2012. It was released later in the year. So you're talking about 3 years. Can't find that in 2014. Unless you were one of the developers on SQL Server 2012. Okay, I'll grant you that. I don't think RTM was 2011. I thought RTM was in fact in 2012. We're gonna see if I have to. Yeah, it was March 6th of 2012. So yeah. Now, if you were on the CTPs, if you were using the community tech previews, maybe. But generally, so CWV mentions that these are small shops that are past the startup phase but never got further. I actually have that on my list of the 4 possible routes that I can see. So yeah, Solomon mentions CTPs. Yes, or if you're one of the developers. I mean, but still, 3 years. Okay, reasons why I think this might be. Number 1, you have somebody in HR who doesn't understand this and just says, we need 3 years, because 3 years says that you have a lot of experience with it. So you need 3 years with this, you need 7 years with that, you need 12 years with this. It doesn't matter, the thing's only been out for 8 years. I once joked that so the Duke mentioned I once joked I had 7 years of Power BI experience because I was working with SSAS before it came out, and Excel 2010, which had Power Pivot and Power Query. I mean, you could talk about Power BI 1. Nobody wants to talk about Power BI 1. That was a train wreck. C# stable release was in 2000. Okay, yeah. I remember them talking about it in 1998. Slashdot called it C Octothorpe, whatever the term is. Yeah, it was still 5 years of .NET. I get you. I'm with you. So, all right. Somebody in HR. Put in a number. Another scenario. You got Janice, who just left the company. Janice has been with the company for like 10 years, and here's all the stuff Janice did during her tenure. You know, she created a few SSIS packages, she worked with reporting services, she built out some database stuff, she wrote some .NET code, did some PowerShell work, and Janice was pretty decent at these things, but obviously did it within a normal person's schedule. But the new person has to understand all of the stuff that Janice did because we need another Janice. That scenario happens a lot. And the next scenario that Anders just hit on is, well, all right, Rebecca needs a promotion. She's been doing a lot of work as a SQL developer, and now she needs to get to that senior developer level so that we can pay her correctly. But we need to post the job publicly because it's a company policy. So, how do we make sure that only Rebecca can get this job? Well, okay, Rebecca, tell me about all of the things that you have done. I mean, you have to be a master with this internal tool that only is available at our company. You have to be able to work with all of these technologies. She can list any technology she's ever worked with. Because, oh yeah, I've worked with that before. And the whole point is, we're trying to get Rebecca the promotion while following the rules and not really wanting anybody else. And you'll see this sometimes with companies. The last case is that you're in essentially that post-startup role that CWV mentioned, where you don't really understand that not everybody needs to work at all roles. Or maybe you are in that startup phase, and you do actually need people who work in all of those roles. Like, I can only hire one tech person, and I need that tech person to be able to handle development, database work, security, and a bunch of other things. Maybe not that well. Maybe not doing everything great. And if so, that's where I would call that out on the resume. I would call that out in the job description, and say, look, here's all the stuff we'd love to have. And you will be working with this stuff. But we realize that this is not, one human cannot be a master of all of these things. And that's what a sane company generally does if they have to work with that. Phones. So Solomon phone screened a person in 2012 who claimed experience with SQL Server 2012. When asked what the favorite feature was, the person said they weren't sure because they had only installed it on their laptop. That's something. That I guess points for honesty, but then you take all of those points away and more because you could have just looked on the website. Like why did you install 2012 and what did you actually get out of it? Apparently not much. So yeah, there's a few different reasons why this could come up. And sometimes you look at the list of things and it's actually not as crazy as it first appears. Like actually this particular one, as I looked at the description, I looked at it and said, okay, you're looking at somebody who's got like 7 to 10 years of experience in development and has been around the block with several other technologies. But the job is for an application developer who needs to do some extra on the side. And parsing through the description, I just got to that. If you simply looked at the list of technologies, that's going to look absurd. But as you look at the full context around it, you're like, oh, okay, yeah, this is an app dev. But again, maybe it's the Janus scenario because Janus worked with the database administrator and made sure that the queries were good, or Janus was the database administrator because we didn't have one. So that does happen. But again, if you want good people, tailor that job description, but be clear what you need to do versus what we'd like you to do, and be honest about that as well. Just recognize that even if it's because somebody's leaving, one person doesn't need to handle all of that work. And you don't necessarily need one person who is really good at all of those pieces because the person who left probably wasn't either. Maybe Janice's PowerShell scripts worked. They did all right. But it might be that she spent a few hours on it and that was her PowerShell experience. Nothing wrong with that. But you don't need a PowerShell expert. You just need somebody who's willing to spend a few hours and learn and carry on. So, all right, everybody. We are going to wrap up this week's edition of Shop Talk. Thank you so much, chat, for hanging around here. Anders has applied for and gotten jobs where he knew nothing about the tech, like replication. Yeah, you don't necessarily need to know the technology. You just need to be able to prove that you can learn it. I mean, that's one of the things where a heavy emphasis on the tech skills themselves is not necessarily healthy in the long run. It's about whether people can adapt to the situation and grow to help out the company. So CWV, tailoring a description of necessities would help make it clearer. Yeah, absolutely. And you just heard me say that, so that's great. We do have about a 15 to 20 second delay just from the nature of Twitch. Actually, one of the things that if I were affiliated, that delay goes down a bit. But that's probably about the only real benefit that our group would get. It does help when no one else knew it as well. Yeah, Anders, that's a good point. Because if somebody comes in and says, oh, I'm Hillary Cotter. Oh, okay. Well, you know what? You can have the job. All right, with that, we're going to wrap it up for tonight. Thanks again, everybody in chat. If you have questions for Shop Talk afterwards, hit us up, shoptalk@tripass.org. And next week, I'm hoping that I will have a nice, big, happy group of people around me, or at least the same surly bunch who are normally here. So with that, good night, everybody. Take care.